differentiation. The equation of a curve is ln x plus y equals x minus 2y. So usually when we're finding dy dx or y prime, we differentiate explicitly because we can rearrange the equation into y equals something. Since there's no way we can rearrange this into y equals something, we gotta differentiate implicitly. So implicit differentiation basically means we ddx both sides. So after we differentiate both sides with respect to x, so for ln something, we use this differentiation formula in the MF19. ln becomes 1 over, so we have 1 over x plus y. But we have to use the chain rule because the argument is not a simple x. We're gonna have to multiply by the derivative of x plus y. The derivative of x with respect to x is just 1. The derivative of y with respect to x, it's not just 1 but 1 dy dx. So just like the derivative of x, we get 1. The derivative of y, we also get 1, but since we have different letters here, this is y, this is x, we have to multiply by dy dx. If this is z, then dz dx. Okay, so for the right hand side, the derivative of x is 1 again. The derivative of minus 2y is just minus 2 times dy dx because, again, different letters. Okay, so now we rearrange the algebra here. We can multiply, open up the brackets, times 1 times this. So that's what we get, and then we move everything with dy dx to the left. So add 2y dy dx to both sides, and then we subtract 1 over x plus y. So we get this on the right, and we can pull out the dy dx. We still have 2 plus 1 over x plus y, and then we divide both sides by this brackets, and now we multiply both parts of the fraction by x plus y. So actually we're multiplying by 1, we're not changing anything, but when we multiply 1 times x plus y, we get x plus y, and when we multiply here, they cancel out, we have only 1. And when we multiply 2 times x plus y, we get 2 times x plus y, and when we multiply this, we cancel out, we have only 1. And this is actually the form we need to prove. Tangent is parallel to the x-axis. So parallel to the x-axis means horizontal tangent. Horizontal lines means the gradient is 0. Gradient means dy dx. Previously we know this is the dy dx. If we are solving a fraction is equal to 0, just use the numerator equals 0. So here we can substitute. If we just add 1 and subtract y from both sides, we're gonna get 1 minus y on the right. And previously we know the original function equation here. We're gonna replace this x and this x with 1 minus y, and after we simplify, ln 1 is 0, and this is minus 3y. This means, subtract 1 from both sides, divide both sides by minus 3, we get the y value. To find the x value, just plug in the 1/3 to this equation, we get the x value. So in conclusion, the coordinates of the point where the tangent is parallel to the x-axis, so this is the final answer. The coordinates of the stationary point, basically. Alright, I'll see you again next time.